Hello, everyone. This is our second asynchronous lecture for Philosophy 1600, reasoning skills. Just to connect the dots, last week, the asynchronous lecture was on a couple of things. First of all, what is an argument, right? And we gave this sort of sterile but functional definition that an argument is a set of sentences that support a conclusion. And typically, the sentences that support the conclusion are called the premises, right? So an argument basically consists of premises and a conclusion. The reasons can be factual, they can be, evaluative, they can be of any type. And the idea is you want the premises to somehow support the conclusion. And in later lectures, we'll get into what constitutes good support for a conclusion, right? But this week, I I want to continue with simply identifying arguments. Okay. So last week we learned two major skills. One was to take arguments that don't have premise and conclusion indicators and to identify them by using the principle of charity. And for deductive arguments, the principle of charity involves a number of basic argument patterns. You're trying to fit the arguer's argument into one of these patterns. And by doing so, you identify the conclusion and the premises of the argument, right? And again, it's in line with the principle of charity because according to the principle of charity, you want to attribute to your fellow discussant, your fellow arguer, you want to attribute to them the best possible argument, the most charitable argument, on the assumption that the person with whom you're arguing is at least minimally rational, right? So that's what is behind the principle of charity. So what we did is we looked at a number of argument patterns that allow you to fit an argument into one of those patterns, right? So just to briefly reiterate, we had things like modus ponens, if P then Q, P therefore Q. We had modus tollens, if P then Q, not Q, therefore not P. We saw that there are invalid versions of those. And by the way, this is all discussed in the text. Affirming the consequent is the invalid version of modus ponens. If P then Q, not Q, therefore P. And the invalid version of modus tollens is called denying the antecedent. If P then Q, not P, therefore not Q. So whenever you're trying to fit an argument into pattern, don't put it into either affirming the consequent or denying the antecedent because those are both valid arguments. Instead, you're going to try to see if you can fit it into modus ponens, if P then Q, P therefore Q, or modus tollens, if P then Q, not Q, not P. We saw some additional valid argument patterns that you might try to fit the argument into. So, for example, hypothetical syllogism, if P then Q, and if Q then R, therefore if P then R, right? Also constructive dilemma, if P then Q, and if R then S, P or R, therefore Q or S, right? That's called constructive dilemma. We also had exclusive or syllogism. If P or Q but not both, and P occurs, and you know that Q cannot occur because it's exclusive or. You have disjunctive syllogism, which applies to both inclusive and exclusive ors. P or Q, not P, therefore Q. That's called disjunctive syllogism. We also had a chain argument where you can combine several valid arguments together to derive an additional valid argument pattern, right? We also had, for example, predicate instantiation. All S's are P's. X is an S, therefore X is a P. So, for example, all humans are mortal. Socrates is human, therefore Socrates is mortal. And of course, you have what is called universal syllogism. All A's are B's, all B's are C's, all A's are C's. So, if you'll have, for example, all humans are animals, all animals are mortal, therefore all humans are mortal, right? So, and what I had you do, one of the exercises on the assignment, which is due this coming Thursday, is to try to figure out what the conclusion of the argument is and to see which argument pattern the argument mimics, right? Okay. So you might say, well, the conclusion is such and such, and it mimics modus ponens, or it mimics constructive dilemma, or whatever, right? Okay. Um, In addition, we looked at adding missing premises to incomplete arguments. So, as I was saying last week, sometimes arguments aren't so neat and tidy. Sometimes people will omit premises. So, there is a way of adding premises. And again, you can use these valid argument patterns for deductive arguments, right? So, if I say it rains, therefore it snows, then chances are the missing premise there is if it rains, then it snows. Again, you're adding a missing premise in line with the principle of charity that generates a valid argument. Okay, so that's what I want you to do for that first exercise. Today's lecture will be the basis for assignment number 2. And there are going to be 2 topics that we're going to discuss in today's lecture. Topic number 1 is how to diagram argument structures. So this is basically this is not an evaluative technique. This is a technique that you use in order to identify arguments, right? And it's a time-honored strategy that has been used by philosophers and logicians for at least 20 years. It was developed by Michael Scriven, all right? And what it does is it allows you to identify an argument in terms of its premises and its conclusion. So this could be highly valuable. Let's say you're writing a paper, and it doesn't matter what subject it's in, English, philosophy, history, even biology or something like that. What you can do is, if you're identifying an argument, you can identify it in terms of using these Scriven diagrams, right? So these can be very useful in terms of identifying arguments. So that's what we're going to look at first. And the second thing we're going to look at is how to evaluate definitions. And as you know, part of reasoning skills involves, if you're writing, for example, an article or a paper, involves putting forward good definitions. So, for example, a lot of scientific articles involve what are called operational definitions. And these operational definitions, a little bit circular, but specify operations that need to be formed for the concept to apply. So I could say, for example, intelligence will be defined for the purposes of this paper as a score on some kind of a test, right? Something like that. So we'll look at, first of all, we'll look at diagramming argument structures. And then the second part of the lecture will be on identifying and evaluating definitions that you find in articles, okay? And that will be the main 2 topics I'm going to cover for today. And then next week we'll, so anyway, so the next assignment then will be based on this current asynchronous lecture. Okay, so let's look at the first topic. It should be on the screen here, diagramming argument structures. So as I say here, we can represent the structure of argumentative passages using very simple diagrams, right? So this isn't a complicated method. It's a very straightforward, simple method. And essentially, it's a way of telling you what the premises are in an argumentative passage and what the conclusion or conclusions are. And so to represent that, we're going to use arrows. It's the simplest technique you could possibly learn, right? So basically, if I have 1 arrow 2, that means 1 supports 2. So 1 is the premise and 2 is the conclusion. The level of support, or whether the support is deductive or inductive, is not part of the system. So we're going to talk a little bit about inductive and deductive arguments more in detail next week. But for this week, just a heads up that this method is silent between whether the argument is inductive, that is probabilistic, or deductive, i.e. the conclusion is entailed with certainty, right? It doesn't tell you about whether the argument is inductive or deductive. It just tells you that these particular sentences are meant to support some other sentence, right? And so you represent that using the arrow. Okay, so as I say here on the slide, if 2 or more premises support the same conclusion, there are 2 possibilities, right? Either the premises could support the conclusion independently, or they could support the conclusion conjointly or dependently, right? Those are the 2 possibilities. So let me illustrate this with a couple of simple examples. So let's go to the next slide. Consider I've got 2 arguments here for you. All humans are mortal. Socrates is a human, thus Socrates is mortal. You'll recognize that again as predicate instantiation. Consider argument number 2. Schools need funding for 2 reasons. First, they need more equipment. And second, they need more teachers. Okay, so frankly, for the first argument, you need both premises to support the conclusion because it's part of a predicate instantiation argument, right? All A's are B's, X is an A, X is a B. So you need both premises, right? From saying that Socrates is human, I cannot necessarily infer that Socrates is mortal. From saying that all humans are mortal, I certainly can't infer anything about Socrates, right? Now, on the other hand, look at schools need funding for two reasons. The reasons I think you would agree are independent of one another. In other words, in the sense that either premise could constitute an argument for the conclusion. So I could say, schools need more equipment, therefore they need more funding. That itself can be considered an argument, right? Or I could say schools need more teachers, so they required more funding. That's a separate consideration, right? So in the second argument, the premises are independent and they support the conclusion independently. So let's go to the first argument. All humans are mortal. Socrates is human, thus Socrates is mortal. In that first argument, as I say here, the evidentiary support is conjoint. All right. We can represent this first argument as follows. So what this says, let's just read it. It says 1 and 2. So if the arguments conjointly support the conclusion, then you write 1 plus 2 together. Underline it, and then have an arrow going down to 3. And what this arrow says is 1 and 2 conjointly support the conclusion. And again, the arrow doesn't tell you whether that support is inductive or deductive. It just tells you that 1 and 2 together support 3. Okay? And that seems to be a reasonable interpretation, a reasonable representation of the argument. So again, what you're trying to do is to represent the argumentative structure of that passage. And so it's 1 and 2 together support 3. Now, with the second argument we looked at, I think it was pretty clear that the premises supported the conclusion independently. So again, let's take a quick look at that. Schools need funding for two reasons. First, they need more equipment, and second, they need more teachers. These reasons are independent of one another, right? Either one of them could constitute a separate argument for the conclusion that students need more funding. Therefore, the diagram will look as it does on this slide, right? You can represent the argumentative structure of the little argument diagrammatically as follows. And what this says is that 1, 2 independently support 3. Or if you want, this is by the way equivalent. 1 supports 3 and 2 supports 3. Either of these convey the same idea about the argumentative structure of that short passage. All right. So again, going back to the passage, we can see that these reasons are independent of one another. So we're going to represent them as independent in our Scriven diagrams, okay? So hopefully that's clear to everybody. Now, that seems all pretty neat and tidy, but the problem is that life is always more complicated, right, than those simple arguments. Usually you get argumentative passages that are fairly complex, all right? So in that case, you might have more than one conclusion. And so you might have a number of arguments nested in a particular argumentative passage, all right? So as I say here, consider the following example on the next slide. So look at this argument here. All mammals are animals. All animals are mortal. Thus, all mammals are mortal. So I think you would agree that this is a universal syllogism. So the two premises conjointly support the conclusion. 1 and 2, arrow 3, right? Okay, that seems reasonable. But then again, you have further, all humans are mammals. So if you put 3 and 4 together, right? In other words, all humans are mammals, all mammals are mortal, then you will get the further conclusion, 5, that all humans are mortal. So here's the deal then. 1 and 2 together support 3, right? That's a universal syllogism. 3 and 4 together support 5. That's a second universal syllogism. So if you look at this passage, we clearly have more than one argument, right? In fact, altogether, we have 2 arguments. And we identify the number of arguments in an argumentative passage by the number of conclusions it contains. So this argumentative passage contains 2 conclusions. 3, all mammals are mortal, and it contains the further conclusion, 5, that all humans are mortal. All right, so this is a good way to represent diagrammatically then the argumentative structure of that particular passage. So far, so good. So again, there are 2 arguments because there are 2 conclusions. So actually, this links with the next slide. How many arguments does the above passage contain? As I just pointed out, conventionally, the arithmetic of arguments is that the number of arguments equals the number of conclusions in the passage. So in the above case, there are exactly 2 arguments present. Sentences 3 and 5 both function as conclusions. So that's how you identify whether or not an argument is present, right? By identifying the number of statements that function as conclusions in that passage. So we say, therefore, that in the previous passage, there are altogether 2 arguments. So what I'm going to do now with you, now that we have the basic theory, so the theory is very simple, right? I mean, what is the theory? It's arrows, right? And the arrows represent inferential links between premises and conclusions. It's that simple. And in terms of the arithmetic of arguments, the number of conclusions that you find equals the number of arguments, right? So if you find 2 conclusions, there are 2 arguments. If you find 3 conclusions, there are 3 arguments. That's simple, right? Okay. Now, it's all good to have a theory, but we need to be able to apply it, right? So let's look at this first passage, and it's a fairly complicated passage. So this is example number 1. It says capital punishment in many cases deters people from committing murder. All right. Now by the way, just to be careful, I am not advocating any of these arguments. We're just describing them and identifying the argumentative structure, right? So no one's advocating anything here. But let's say that someone writes an editorial, right? And they say, well, capital punishment in many cases deters people from committing murder, and reducing the murder rate is in self worthwhile. Okay. So 2 statements, right? Capital punishment deters murder, and reducing the murder rate is, of course, worthwhile, right? Okay, that's one consideration. Now, here's a separate but important consideration regarding capital punishment. They say here that executions are also less costly to society than is the alternative, life imprisonment. So, and I've heard people that argue that, right? I'm not saying that I agree with it, but some people will say, well, it costs more to keep someone incarcerated for, let's say, 30 or 40 years than it does to execute them immediately, right? So one could argue that executions are more cost effective than life imprisonment. Moreover, and this goes with the previous statement, someone who has murdered another person doesn't have the same claim on taxpayers' money as do other causes. So you and I, as law-abiding citizens, have a certain demand on the taxation that the government takes in. For example, I might write my municipal government and say, we need better streets in front of my house. And I'm perfectly legitimized in asking for that because I'm a law-abiding citizen. I respect the rule of law, right? But suppose you have someone that breaks laws. Then what this argument is saying is if you break laws, you don't have the same right to take taxation money that other people may have, right? So that's the gist of the second argument. Then there's a third one. And again, it's a separate set of considerations. It says, and in any case, a murderer has, by the act of murder, committed a wrong which can only be rectified by an equivalent punishment. All right. So the idea is if I steal, then the equivalent punishment would be to pay the money back. If I commit murder, according to this view, then the equivalent punishment is to forfeit my life. And so that's made explicit in the next statement. The equivalent punishment is forfeiting one's life. And so the overall conclusion, now this is important. I don't know if any of you are taking the LSAT, but they have a reading comprehension section. And in the reading comprehension section, they'll give you a complex passage and they will ask you to identify the conclusion, right? So in this case, the main conclusion of this huge passage is that the penalty for murder should be capital punishment. And they're giving you 3 separate sets of considerations, right? One consideration is that it deters. A second consideration is that it's less costly to society. And a third consideration is that capital punishment is equivalent to what the criminal did, namely taking someone's life. So those are all 3 separate considerations for capital punishment. And so that gives rise to the diagram on the following slide. 1 and 2 together support 7. 3 and 4 together support 7, and 5 and 6 together support 7, right? So now you might be asking, okay, so then it looks like there are 3 arguments in the passage. Well, frankly, according to the arithmetic of arguments, there is only one conclusion, 7. And so we will say then that because there's only one conclusion, that there is just one argument. You could say that there are 3 kind of sub-arguments within the main argument, but these sub-arguments constitute the same argument. And so we say that there's just one argument because there's only one conclusion. So 1 and 2, support 7. So let's go back. Let's just go back for a second. All right. So the idea is that it deters, and deterrence is worthwhile. Those go together, right? To say that um, executions are less costly to society and people that commit murder don't have a claim on taxpayers' money go together to support capital punishment is justified. And finally, a murderer has committed a wrong which needs to be rectified by an equivalent punishment, and the claim that the equivalent is forfeiting one's life. Those two go together as well to support the conclusion. And so that's why we have the diagram on the next slide. 1 and 2 together support 7, 3 and 4 go together to support 7, and 5 and 6 go together to support 7. But because there is just one conclusion, then we say that there is only one argument present, right? Okay. Now, by the way, this is an important caveat. I can equivalently represent the argument as follows. All right. 1 and 2 support 7, 3 and 4 support 7, 5 and 6 support 7. And this conveys the same information that was conveyed on the previous slide. It's the same thing. You can say, well, look, McPherson, if you've got 3 7s, then that means you have 3 conclusions and therefore 3 arguments. Well, my reply is, well, not really, because 7 is the same conclusion for all 3. And therefore, it really is just one argument, right? So there are altogether here one argument because there's only one conclusion. Okay, let's do another example. Example number 2. Government-funded efforts to save the whooping crane, are paying off, and I, for one, am delighted, right? This is clear evidence that government funding can be effective in helping to preserve endangered species. There is no question, therefore. Notice that the word therefore is a conclusion indicator, right? That government-funded programs to preserve endangered species should be continued. So I think it's fair to say, especially in the light of the conclusion indicator, therefore, that the overall conclusion is that government-funded programs to preserve endangered species should be continued. Why? Well, because government funding can be effective in helping to preserve species. Why? Well, because so far those efforts have been successful. So it would seem then that 1 supports 2 supports 3. By the way, notice this statement here, and I, for one, am delighted. Okay, so that's fine. It's okay, but it doesn't play any role in the argumentation in the passage. It is kind of an aside. I'm just saying, well, and by the way, I'm delighted that that's the case, that these efforts are paying off, right? Because a lot of people are, of course, very much in favor of species conservation, right? And that's perfectly okay, but it doesn't play any role in the argumentation. We call statements or parts of sentences that don't play any argumentative role in a passage, we call them extraneous material. EXTRANEOUS, extraneous material. They don't play any argumentative role in the passage. So if you look at the diagram on the next slide, it's 1, which again is these efforts to save whooping cranes are successful. 2 is therefore that given that they're successful, then government funding can be effective, right? Because we have evidence. And because government funding can be effective, then 3, we should continue with government funding, right? So then we therefore have 1 supports 2, 2 supports 3. So notice that in this diagram, you have one of the statements 2 functions as both a conclusion in the subsidiary argument, but it also functions as a premise in the additional argument, right? So the question is, how many arguments are present. And in this case, we would say that there are two conclusions, 2 and 3. And therefore, there are uh, two arguments present, right? Because we have two conclusions, number 2 and number 3. Let's go to a third example. This I got from a textbook. I forget which textbook it was from now. That's why I put it in quotation marks, okay? So this is not my own inventions from a textbook. Anyway, police officers are damned if they do and damned if they don't. All right, okay, fair enough. How often do we hear comments from the public when they see traffic violations or hear of unsolved crimes to the effect that there is never a police officer around when one needs one? So I'll give you an example. My own neighborhood, there's a guy that rides a chopper, and I have nothing against choppers, but he must be going at least 80 kilometers an hour down the street. Now, there are kids on this street that play in this street, right? And so I wonder, like, where the heck are the cops? Where's the Windsor police, right? So I mean, this is something that I would say too. So we often hear comments from the public, like myself, that when we see traffic violations, there's never a police officer around when they're needed, right? On the other hand, a lot of people complain. Let's say I'm driving down to Tecumseh, I'm maybe going, I don't know, 10 or 15 kilometers over the speed limit, and a police officer pulls me over. I might say, "Ah, darn it, why they're over enforcing the laws." But so we often react that way too. We react in two ways. If we have a trouble in our neighborhood, we want the police here right away. But let's say we maybe go through red light by mistake or something, and a police officer pulls you over. A lot of people will say, "Darn it, man, they're being too vigilant." So therefore, both things are true, right? Police officers are damned if they do, and they're damned if they don't. People complain when they're not there, and people complain when they are there. This gives rise then to the following argument, all right? 2 and 3. So let's go back. 2 is we hear comments from the public that there are never police officers around when we need them. So that's 2. 3 is that when the officer is doing a job, we also complain, right? That's 3. So together, these two statements support the claim that police officers are damned if they do, and they are damned if they don't, right? So because it's a conjunctive conclusion, it requires conjunctive premises, 2 conjoined with 3. So if you look at the arithmetic of arguments, you would say that altogether there is only one argument in the passage because there's only one conclusion in the passage. Is that fair? Okay. Last example. And then I will post more examples that I'll get from Vaughn's text as well that you can go over in your lab next week. Okay. So anyway, here's the last example. Again, I got this from I think a logic textbook, so I put it in quotation marks. Sorry that I didn't cite the book, but anyway, it says some wars are right and some wars are wrong. Okay, seems reasonable. Okay, so that's one claim. Now they go on to say the Soviet invasion of Afghanistan was unjust because it was used to promote imperialism. So long before the U.S. went to Afghanistan, following 9/11, the Soviets had tried to invade and take it over, and they didn't have success, right? And it was basically an imperialist agenda. On the other hand, some people might argue World War II was just because it was an attempt to stop Nazi imperialism. So if you know anything about history, you know that Hitler took over Czechoslovakia, he took over Poland, he took over France, he took over Finland, right? And his goal was to take over the entire European continent, right? Okay. So clearly he was imperialistic. So here's the claim then. The Soviet invasion of Afghanistan was unjust. And I think a lot of people would say that the World War II was just because we were trying to stop Hitler, right? So if you put those two together, then it seems to follow that given that some wars are right and some wars are wrong, it follows that we should be cautious before entering a war. Does everybody agree that those two premises need to go together, right? In other words, we should be cautious before entering a war. Sometimes they're just, but sometimes they're not, right? So given that sometimes wars are right and some are wrong, it follows that we should be cautious before entering a new war. Okay? My interpretation of this argumentative passage is on the next slide. 2 and 4 Some wars are just and some wars are unjust, right? Conclusion, we should therefore be cautious before entering a war. Notice that you need both of these to support the conclusion, right? Why do we need to be cautious? Although sometimes wars are just, they can also be unjust. So we have to kind of, take a second look and see what's going on. Now, here's the thing, though. You might say, well, where the heck do 3 and 5 come from? Well, the thing is that 2 and 4 are supported by further premises. So look at 2. The Soviet invasion of Afghanistan was unjust. But notice that the word because is a premise indicator, right? And what follows is a premise. The reason that the Soviet invasion of Afghanistan was unjust is because it was used to provide imperialism. Therefore, 3 supports 2. Okay, let's go back. We also agreed that World War II was just, but there is a reason for that. Because, again, a premise indicator, it was an attempt to stop Nazi imperialism. Therefore, 5 supports 4. If we put 2 and 4 together, then we get 1. And 1 is that some wars are right and some wars are wrong, and therefore that we should be cautious before entering a war, right? Some wars are just, some wars are okay, therefore we should be cautious before entering a war. All right. Oh, sorry. My apologies. I went to the wrong slide. Okay. And so we get this diagram here. Okay. So is that good for everybody? So that, in a nutshell, is how you do Scriven diagrams for argumentative passages. And so one of the exercises on assignment number 2 will be to give me some Scriven diagrams for an argumentative passage and also to tell us how many arguments are present. So again, let's just look at the arithmetic of arguments. So in this diagram here, we can see that there are 3 conclusions, right? 2 and 4. 2 is a conclusion of 3. 4 is a conclusion of 5. Then 2 and 4 together entail 1. So there are altogether 3 conclusions, 2, 4, and 1, and therefore there are 3 arguments. So in that passage there are altogether 3 arguments, all right? So that's one of the tasks that I want you to perform on assignment number 2. So if everybody is good with that, then let's go on to topic number 2 for today's lecture. Okay, there we go. Okay, good. All right. The second topic we're going to look at in this asynchronous lecture is the theory of definitions. Now, those of you that are in science know that definitions are very important. For example, if I'm reading a scientific journal, scientific article, right? I publish in science as well as philosophy. Usually, if I'm publishing in science, I will give an operational definition of what it is that I'm trying to quantify, right? So, um, and so basically definitions are very important, especially in scientific literature, but even in philosophical literature as well, right? So let's take a look then. What is a definition? So here, and by the way, these notes here come not really from what's his name, Vaughan and McDonald and Vaughan. This comes really from Copy and Cohen, right? Okay, so this comes from Copy and Cohen's Introduction to Logic. You can easily get a free copy online. So here's the theory of definitions, right? So first of all, what is a definition? So I'm going to give you a definition of definition, right? A definition is a group of words or gestures used to assign a meaning to a term, right? So I could say an ambulance is a vehicle used to transport people in emergencies. A bicycle is a vehicle with 2 wheels driven for the purpose of transportation and so on. So these are definitions, right? And a definition is a group of words or gestures, right? It can be words, but it doesn't have to be words. For example, you could say, what is an auto beam? I could say, that thing over there. Well, if I point with my finger and say that thing over there, that's more of a pointing. That's an action definition, right? Rather than it's a gesture. It's a definition using gestures. So definitions can either involve using words, definition words or gestures, right? And the purpose of a definition is to assign a meaning to a term. So if you ask me, what is a triangle? And I say a triangle is a 3-sided figure, then what I'm doing is I'm assigning a meaning to the word triangle. There are two kinds of meanings. One kind is called the extension of a term. And the extensional meaning of a term is the class of things that it denotes. So, for example, go back to triangles. A triangle, what is an extensional definition? A triangle is isosceles. It is right-angled. It is obtuse, right? It is equilateral. These are all definitions of, these are all things that the word triangle denotes. So that's called an extensional definition, right? On the other hand, the intension of a term gives you a list of traits that something must satisfy to be denoted by. Okay, so let me give you an example. Again, going back to triangle. A triangle is a three-sided figure. Being a three-sided figure are traits that something must have to be called a triangle, right? A square doesn't qualify because a square has four sides and not three sides. So it would not be what a triangle is. So again, the extension gives you the list of things the term denotes, and the intension gives you the list of attributes that something must satisfy to be in the extension of the term. If that's true, then it follows that intension determines extension. What the heck does that mean? Well, it will become clear in the next slide. Given the relationship between intension and extension, we can order terms with respect to increasing and, sorry, that should be decreasing intension, extension. Generally, not always, but generally speaking, as the intension of a term increases, its extension decreases. So the more traits that something must have to be in the attribute, to be in the extension of a term, uh, the the extension decreases. So I could say, well, the extension of triangle is much broader than the extension of an equilateral triangle, right? So an equilateral triangle not just has three sides, but the three sides are equal. Then in that case, that triangle, uh, equilateral triangles, is a lesser class than triangles generally, right? Because of course triangles can be of different types. So the general rule of thumb then is that the intension of a term, the list of attributes that it has, determines its extension, right? Being three-sided determines triangles. Being three-sided with all sides being equal determines a lesser set of triangles, namely equilateral triangles. So let's illustrate this general maxim with some concrete examples. So let's go to the next slide. So what I've done here is I've put down different terms, and the terms have increasing intention, right? So let's look at at number A. You have horse, animal, mammal, living thing. So remember the maxim: as intention increases, extension decreases. So you would agree that living things involves all kinds of stuff: animals, mammals, insects, plants, bacteria, right? Fungi. Living thing is a very, very broad category. So I think you would agree that living thing has the biggest intention and therefore the broadest. So it has so the intention increases. So it denotes basically everything. All right. Sorry, I should say that it has a low intention and a high extension, because a lot of things can be regarded as living things. And so it's a very broad kind of definition, right? Now, what's the next less general intention? Well, I guess that would be animal, right? So some living things are animals. Animal has a slightly bigger intention. Has a slightly bigger intention, but it has a smaller extension, because living things can include both plants and animals, but animals is much stricter, right? So therefore, the intention animal is higher than the intention of living thing, but its extension is lower. Now, some animals are mammals, right? For example, lizards are animals, but they're not mammals. So mammal has a much bigger intention than does animal, right? For example, a mammal is an animal that is warm-blooded, right? For example, right? And has certain other features, all right? So therefore, it's a much bigger intension, but a smaller extension. Mammals denotes many fewer things than animals, and animals denotes many fewer things than living things. And the term with the highest intension and with the lowest extension is horse. So a horse is a particular kind of mammal with certain kinds of taxonomical features, right? So this illustrates that as the intension increases, the extension decreases. Living thing, its intention increases when you go to animals, and the extension decreases. When you go from animals to mammals, the intention increases, but the extension decreases. And when you go from mammal to horse, the intention increases, but the extension decreases. So as intention increases, extension decreases, just a general rule of thumb. Let's look at the next list below that, okay? Horse, mammal, unicorn, winged unicorn, all right? So I think you would all agree that the broadest term there is mammal, right? Because not all mammals, of course, are horses, are they? So mammal is the broadest term. It has the lowest intention, but it has the highest extension. Lots of things are mammals. Human beings, dogs, cats, mice, right? Horses. So mammal has the broadest, I guess you would say, extension because it has the lowest intention. Now, if I define mammal, if I define a horse is a much stricter category than mammal. So the intention of horse is much greater than the intention of mammal. And the intention of horse is much less than the intention of mammal. Mammal denotes all kinds of different animals, right? Whereas horse only denotes a particular kind of mammal. Moreover, now these are mythical creatures, right? But a unicorn is supposedly in mythology a horse that has a horn. So unicorn has a higher intention than horse and a lower extension, right? And then winged unicorn has even a lower extension because it has an even higher extension. Namely, it's a unicorn and it's winged. Now, one caveat here is that unicorn and winged unicorn denote the empty set. So strictly speaking, although the increasing intention from mammal to horse decreased the extension, going from horse to unicorn and winged unicorn, the extension is empty in both cases. They're fictional entities, right? At least as far as I know, I've never seen a unicorn, and I've certainly never seen a winged unicorn. Let's look at list number 3. Okay, C, figure, four-sided figure, rectangle. I think you would all agree that the most general term here is figure. Then four-sided figure, right? And then rectangle. So basically the intention of figure is the smallest, but its extension is the largest, right? For example, a circle is a figure. Then if you go to a four-sided figure, its intention is greater than figure and its extension is less because again, there are a lot of figures that aren't four-sided. And not all four-sided figures are rectangles. So rectangle has the highest intention and the lowest extension, right? For example, a square is a four-sided figure, but it need not, well, I guess actually all squares are rectangles, but let's say, for example, um, but certainly at the very least, rectangle is more specific than four-sided figure, okay? All right, number D, car, vehicle, motorized vehicle, inexpensive car. All right, so again, we're trying to look at which has the highest intention and therefore the lowest extension. Well, I think you would agree that the term that has the greatest extension is vehicle, right? And it has the lowest intention. Vehicle be a bike, a car, a plane, a motorcycle, whatever, right? So this is our most general term. It has the lowest intention and the greatest extension. Then we go to a motorized vehicle. Well, not all vehicles are motorized. For example, bicycles are often not motorized, right? So a motorized vehicle has a greater intention than vehicle, and it has a lower extension. There are fewer motorized vehicles than there are vehicles. And finally, we go to car. Well, car is even more specific than motorized vehicle. A bus is not a car, but it is motorized. So therefore, the car has even greater intention than motorized vehicle, and therefore a lower extension. And finally, not all cars are inexpensive. For example, a Maserati, right? a let's say a Carrara turbo. They are cars, but they're expensive cars. So any expensive car would be even more specific, and it will have an even lower extension. Last list: sport, activity, team sport, baseball, hardball. Clearly, activity is the most general. It has the lowest intention. Then we go to sport. Well, sport is a kind of activity. Not all activities are sports. For example, an example of an activity is walking to the corner store to buy something. That's an activity, but we wouldn't call it a sport. A team sport has an even higher intention and a lower extension. Not all sports are team sports. For example, you could argue that, I don't know, what's an example of a singular sport? Maybe solitaire, arguably, is a sport, but it's not a team sport. And then baseball is more specific than team sport, and it has a lower extension. In other words, there are a lot of team sports: soccer, football, right? In the American sense of the term, baseball, whatever it might be, right? Okay. And then, of course, baseball is hardball is more specific than baseball because, as you know, there are different kinds of baseballs. For example, there is softball, there is hardball, right? Okay. So anyway, this is just to get clear on the overall principle that as intention increases, extension decreases. Okay, now remember I said that there are two kinds of definitions. There are extensional definitions that assign a meaning to a term by laying out the things that it denotes. And then there are intensional definitions that assigns a meaning to a term by laying out a list of attributes. So let's look at different kinds of extensional definitions. One type of extensional definition is a pointing definition, right? So if you say, what is a car? And I just point and I say, that over there is a car, then that is an ostensive definition. Quasi-ostensive definitions involves both pointing plus words. So again, if you ask what a car is, I just point, that's ostensive. If I point and I say that is a car, then that is a quasi-ostensive because I'm using both language and gestures. There are also definitions by example. You could say, well, McPherson, what is a car? You could say, well, a car is a Toyota, Ford, a Chrysler, a Fiat, a Volkswagen or whatever, right? So I'm giving you definitions by example. I'm not telling you what a car is in the intentional sense. I'm just giving you a list of things that count as cars. And then there's what is called a definition by subclass. You could say, well, McPherson, what is a house? I could say, well, a house is a ranch, a colonial, whatever. So basically there are different kinds of houses, ranch, colonials. You have, what is it, the houses where you have two families living in one structure, that sort of thing, right? Duplex, I think is what they're called. So anyway, there are various then kinds of extensional definitions. There are ostensive, which involves pointing. There are quasi-ostensive, which involves pointing in language. There's definition by example, right? Like a car is a Toyota. I could say a triangle is an equilateral, is an isosceles, is a right angle, is an obtuse, right? And definition by subclass, again, so basically, a house is a ranch, colonial, etc. Okay, so just as there are different kinds of extensional definitions, there are different kinds of intensional definitions. Okay, for example, there are what are called etymological definitions. Basically, it trades off an unknown intention for a known intention of a term with which it originated. So, to make a long story short, an etymological definition gives you the roots of a term that you're looking at, the linguistic roots. For example, I could say that the word ambulance in English comes from the Latin verb ambulo, which means to walk in Latin, right? So etymological definitions look at the roots of terms. I could say someone is acting in a puerile manner, all right, namely a childish manner. I could say, well, actually, the word puerile comes from the Latin word puer, which means boy, right? So that's called an etymological definition. If you look at a traditional dictionary, they'll not just tell you the different meanings of a term, they'll tell you its etymology, where it came from in terms of linguistic origins. Another example, psychology comes from the Greek root psyche, right? And logos. Then you have what are called synonymous definitions, and you're trading off an unknown intention for a known intention. So a term that means the same thing. So I could say oculus means eye doctor, right? Those two terms are synonymous. So that's called a synonymous definition. Another kind of intentional definition is called operational. It specifies certain actions or operations that must be performed for a term to be applied. So I could say intelligence is determined by one's score on a standardized test, right? That's an operational definition of intelligence. Genus and difference. It defines a term by locating its extension in a broader class or genus via a so-called specific difference. So here's a concrete example. I know that sounds kind of technical, but here's a specific example. A triangle is a three-sided polygon. The word to be defined is triangle. Polygon is the genus, and three-sided is a specific difference. So that's called a definition by genus and difference. A car is a motorized vehicle used for transportation. Vehicle is the genus. Used for transportation and motorized are specific differences. So those are called definitions by genus and difference. So just for practice, what if we try to classify the following definitions, all right, in terms of whether or not they're intentional or extensional? Let me look at the first one. A derivative for an expression of the form y equals x to the exponent n is a result of applying the formula n times x to the n minus 1. All right. So, for example, let me give you a simple example. The derivative of x squared is 2x, right? Okay. So that definition, I would say, is perhaps an operational definition. It's intentional, but it involves a certain operation that you have to perform, namely an arithmetic operation. So that would be an intentional definition and in particular an operational. Okay, let's look at the next one, right? Sorry for the mathematical examples. A matrix is a collection of numbers arranged in a fixed number of rows and columns. So if any of you have taken matrix algebra, you know that a matrix is simply a collection of numbers arranged into a fixed number of rows and columns. Okay, so what type of definition is that? I would say that this definition is intentional. It's not giving you examples of matrices. It's simply giving you a set of attributes. It's a collection of numbers arranged into a fixed number of rows and columns. Notice that collection is the broadest term. So the genus is collection. And the specific difference are numbers. And then arranged into rows and columns is another specific difference. So your best bet here is to call this definition an intentional definition by genus and difference. Let's look at the next one. A computer is a Dell, a Mac, or an IBM. I think you would agree with me that that definition is an example definition, and it's a definition by example, right? You know, a Dell, a Mac, and IBM are kinds of computers. So it's not intentional. It's not telling you what a computer is. It's giving you examples of computers. So it's definition by example. It's an extensional definition. Let's look at the next one. The word principle originates in the Latin word principium, meaning fundamental. I think you would agree that that is an etymological definition. It's looking at the linguistic origins of the word principle. The word principle originates in the Latin word principium, meaning fundamental, is a definition that is etymological in nature, right? Okay. And the final one, in Britain, a chemist is what in the US is called a pharmacist. So a friend of mine, her dad, right, when he lived in Britain, was called a chemist, right? But what that meant in Britain is that he was a pharmacist. So if let's say you're in Britain and we're walking, I don't know, in London and we see chemist, and you say, what the heck is a chemist? And I could say, well, it's basically what in the US or Canada is called a pharmacist, right? So this then would be a synonymous definition. In Britain, a chemist is what in the US is called a pharmacist, all right? Okay, so does that make sense? So again, just to review, the first one on top was an operational definition. The one below that was a definition by genus and difference. The one below that is an extensional definition by example. The one below that is an etymological definition because it's looking at the origins of the word principle. And the one we just looked at is called a definition by synonymy because chemists in Britain is synonymous with pharmacists, right? So that's an intentional definition by synonymy. All right, so that should give you a pretty good idea as to how to categorize definitions. Now, another important topic regarding definitions is what the heck are definitions used for? Well, there are a lot of different uses for definitions, right? For one thing, a definition can be used to stipulate a meaning of a new term. So, for example, I'm sure you've all seen exponential notation. I could say 10 to the n power is by definition 10 times 10 times 10 n times, right? That's called a stipulative definition. A TV, or sorry, a wristovision is a TV worn on the wrist, right, as a watch. Okay, those are stipulative definitions. I'm assigning a meaning to a new term. Okay. Or I could be taking an old term and giving it a new meaning. For example, until the advent of the internet, the word net just meant, I don't know, a fishing net, a butterfly net. Now, a net can also mean, a website or something like that. So that's a stipulative definition. A definition can be used also to make a term more precise. So, as you probably know, in different provinces in Canada and in different states in the US, there are different definitions as to what constitutes driving under the influence, right? I think they call it, they think they call it DUI or something, driving under the influence, right? Okay, well, in some provinces or states, it can mean having a blood alcohol level of 0.10 or higher. In some provinces or states, it's having a blood alcohol level of 0.08 or higher, right? So the definition can be made more precise. So let's say that, I'm a police officer and I pull someone over and I say, look, I think you might have been driving under the influence. I can't really charge you with that until I use a test to determine what your blood alcohol level is, right? So to be more precise, to see whether you are driving under the influence, I have to do a test, right? So that's called a precising definition. A definition can also be used lexically. And what a lexical definition does, you'll find those in dictionaries, is it disambiguates a term that has multiple meanings, right? So I'm sure, as you know, in many languages, the same term can have multiple meanings. So usually a place that you find lexical definitions are in dictionaries, right? And the lexical definition that you find in a dictionary will outline the various meanings or uses of a term. So I'm giving you a simple example here. An organ is one, a collection of tissues with a common function, two, a musical instrument, right? And so forth. So what a definition that is lexical does is it tells you the different meanings of the term. And as a result, you're getting rid of the ambiguity of a natural language term. Now, by the way, a definition can also be used theoretically. So, for example, it's always used in science. I don't know if any of you have taken general chemistry, but you learn general chemistry, the ideal gas law, PV equals nRT, right? Pressure times volume equals N, which is that Avogadro's number? I forget now. It's been a while since I've taken chemistry. R, which is a constant, and then T, which is temperature, right? So, and the thing about these definitions is that they allow you to make predictions. So let's say you're doing a chemistry problem, and they say, the pressure of this gas is X, right? And the temperature is Y. Then given the pressure and the temperature, I can then predict what the volume will be, right? So the purpose of theoretical definitions is to enable me to make predictions. So for example, if you can give me a value of T, I can predict the value of P. For example, we know that temperature and pressure are directly proportional. So if you increase the temperature, then you increase the pressure. For example, if you have cars or whatever, or if you have bicycles or whatever, you know that in the winter, your tires tend to deflate. And that is because it's a lower temperature, so the kinetic energy of the molecules is less, so the pressure decreases. But you also know that in the summertime, the tires will reinflate because the temperature increases, therefore the kinetic energy of the molecules increase, and therefore the temperature increases, or the pressure increases, right? So that's called a theoretical definition. You can use it to make predictions. And finally, another use of definitions is they can be used persuasively, right? If it has the ability to alter people's attitudes, right? So, for example, I could say a senator in Canada is an elected official who greedily takes perks from lobbyists. All right. Well, that's kind of a cynical definition. It's persuasive. It doesn't really tell you what a senator is. It's trying to, sway your emotions to have a negative attitude. So that's another way that you can use definitions is persuasively. So let's get a little bit of practice, okay? For each of the following definitions, indicate whether it is, first of all, intentional or extensional, what type of intentional or extensional definition it is, and what its probable use is, right? So is it intentional or extensional? If it's intentional or extensional, what type of intentional extensional definition is? And finally, what is the probable use? So let's look at the first one here. A car is a motorized vehicle used for transportation, all right? Well, I would say that definition is intentional because it's not giving examples, it's listing a series of traits. So I would say it's intentional. And vehicle is a general term, motorized and transportation are specific terms. So I would say that it's a definition by genus and difference. And typically, definitions by genus and difference are used to lexically to convey the meaning of a term. So it's a lexical, intentional, genus and difference definition. Let's look at the one below it. The term kinetic energy means 1/2 mass times velocity squared. All right. Well, it seems to me that this is a synonymous, or sorry, my apologies. No, it is. It's a synonymous definition. So I'm saying that kinetic energy means the same thing as 1/2 mass times velocity squared. And as we all know, synonymous definitions are intentional. So it's intentional, synonymous. What is it used for? Well, it's used to make a prediction, right? If I know what the mass and velocity is of a particle, I can then predict its kinetic energy, right? So this is a definition that is intentional, it is synonymous, and it is used theoretically to make predictions. This is one I mentioned a little earlier. Wrist division will mean a television worn as a watch. That is a stipulative definition, right? I'm telling you, so it's being used stipulatively. Is it intentional or extensional? Well, I guess it's intentional because it's listing characteristics. And in particular, television is broader than watch, being worn as a watch. And so it's an intentional genus and difference definition that is being used stipulatively. A few more examples. An SUV is a gas guzzling vehicle that is very dangerous to drive. Well, I would say, first of all, it's intentional because it doesn't list kinds of SUVs, right? It just tells you list characteristics. So it's got to be intentional. And I would say that it's genus and difference because vehicle is a very general term. Gas guzzling, dangerous to drive are specific differences. So I think the best take here is it's an intentional definition by genus and difference. But notice how negative it is, right? So I would say that it is being used persuasively. It's being used to give people a negative attitude towards SUVs. Okay, here's another definition. A website is a region of cyberspace where information is provided. I guess that it's also intentional, right? Because it's not giving you examples of websites, right? Like, for example, Twitter is a website, right? Facebook is a website, all right? YouTube is a website. So I'm not giving you examples, I'm giving you characteristics again. So again, it's got to be another intentional definition. Region is very specific, right? Cyberspace is less specific. Information provided is more specific. So it's clearly an intentional definition by genus and difference, where the genus is I guess, region or perhaps cyberspace. And I don't think it's being used persuasively, so I think it's fair to say it's being used lexically. Okay, what about the next definition? The word solitude comes from the Latin adjective solus, meaning alone. Well, clearly, we're looking at the etymology of the word solitude. So it's intentional etymological, and there's no persuasiveness going on here. So I guess it's just a plain old, it's being used lexically. So the final verdict then is that it is a intentional etymological definition that is being used persuasively. Okay. A hypothesis is an educated guess, or a hypothesis can be a bold conjecture. Both of those are intentional definitions by genus and difference. There's a guess is general, and educated guess is more specific. Conjecture is general, bold conjecture is more specific. So they're both intentional genus and difference definitions, and I assume that they're being used lexically. Last one, morality refers to the forcing of one's opinions on someone else, right? Okay. Well, I'm going to have to say that it's intentional because it's not giving examples of morality, it's giving characteristics. And if you look at it, so it's intentional. What type of intentional? Well, it says forcing someone. Well, there are different ways you can force someone. You can force them physically, or you can force them by giving your opinions to them. So giving one's opinions is more specific than forcing. So I think a fair verdict here would be intentional definition by genus and difference, but you can see it's kind of a negative definition of morality. So I think it's fair to say that it's an intentional genus and difference definition used for the purpose of persuasion, to make someone have a negative attitude towards morality. Okay. So hopefully this is very clear to everybody. The last topic I want to talk about regarding definitions and for today is how to assess definitions, and in particular, how to assess genus and difference definitions. So let's look at the next slide. So let's go through these. These are 5 criteria for assessing genus and difference definitions. Okay, here's criterion number 1. A good definition provides the essential attributes of the species. Suppose you ask me, well, McPherson, what is a car? And I say, well, a car is a 4-door vehicle. Well, that's not really a very good definition because although being a vehicle is essential to being a car, being 4-door is not. There are cars that are 2-door. There are cars that have 3 doors, right? Like hatchbacks. So therefore, it's not a very good definition, frankly, okay? Because having 4 doors is not essential. So we say it's a bad definition because it doesn't provide all of the essential attributes of the species. All right. Let's look at rule number 2. A definition should be not circular. What that basically means is that if you're defining a term and you use it to define it, then it's a circular definition. In other words, the term to be defined, if it's synonymous with the term that's defining it, then it's not a very useful definition. We call that a circular definition. So I'll give you an example here on the slide. Sound is the emission of sonar waves. All right. This is a bad definition because sonar means sound. So what I'm telling you is that sound is the emission of sound. Well, that's not a very good definition. That's circular, right? The term to be defined is the same as the term you're using to do the defining. So that's a circular definition. So a good definition is never circular. Rule number 3. A good definition is neither too broad nor too narrow. Okay, so what does too broad mean? It means that I define a term in such a way that it includes too many things. So I could say, for example, too broad. I could say that a car is a motorized vehicle. Well, that's too broad because, not all cars are motorized, right? Or maybe too narrow. Actually, that would be too narrow. Not all cars are motorized, so that would be too narrow. I could say a car is a 4-door vehicle. Again, it's too narrow because not all cars are 4-door. So, and you can also make something too broad. For example, what if I say the following? A triangle is a figure. I think you would agree that that's way too broad because that definition includes squares, rectangles, parallelograms, circles. So the definition is too broad. So a good definition by genus and difference should neither be too broad nor too narrow, right? And I think you'd agree with me that that's a good criterion. A fourth criterion is that a good definition is neither vague nor figurative. All right. So what does that mean? Well, if I say poetry is the music of the soul, you're going to say, what the heck does that mean? Right? It is a genus and difference definition because music is more general than the soul, but it's a very bad definition because what the hell is the music of the soul, right? It's perfectly figurative or vague. It doesn't tell us anything, right? And the last important rule for evaluating definitions by genus and difference is that a good genus and difference definition should not be negative. Now, by negative, I don't mean emotionally negative. By negative, I just mean the word not. So if you ask me, well, what is light? And I say, well, light is the absence of darkness. That doesn't tell you anything, right? Okay, so light is not darkness. Okay, we know that, but that doesn't tell me what light is. So a good genus and difference definition should never be negative. And so these 5 criteria together give you excellent ways of evaluating definitions by genus and difference. So again, let's get a little bit of practice, all right? For the following genus and different definitions, evaluate them using the rules, and suggest an improved definition that avoids the flaw. So let's look at the first one here. I could say a teacher is someone who gives instruction to children. I think you would all agree that that definition is too narrow, right? Because teachers often instruct adults. So, for example, I teach university. I don't teach children, yet I'm still a teacher. So clearly, teaching children is too specific. In addition, teaching children is inessential because you can be a teacher and still not teach children. So it commits 2 flaws. If I may go back, the first flaw commits is that it doesn't specify the essential attributes of the term. And it is also too narrow, because you can be a teacher without teaching children. Let's look at the next one. Knowledge is true opinion. That one's really too broad because there are a lot of things that I have true beliefs about, but I may not know. For example, I have a true opinion that E equals MC squared, but I can't tell you how to prove it. So you can have a true opinion without have knowledge. So therefore, that definition is too broad. A lot of things you have opinions about that are true, but they may not be things that you know. Okay, the one below it. A belief is an attitude towards something. Well, I have a lot of attitudes towards things, and they don't have to be beliefs. They can be hopes, desires. So it's just way too broad, right? It includes too many things. Below it, a work of art is an idea expressed in painting or sculpture. Okay, well, for example, would you agree that a great novel can be, like, for example, one of Dickens' novels, like Oliver Twist, or Victor Hugo's Notre Dame de Paris, right, are fantastic works of art, but they're neither paintings nor sculptures. So therefore, it's too narrow, right? Because it rules out a lot of other things, like a great novel or dance, for example. Interpretive dance can be regarded as art, right? Okay, so it's too narrow. In addition, it's inessential because Hemingway writing a great novel, or Dickens writing a great novel, or Dostoevsky, like Crime and Punishment, right? It's a great work of art, but it's neither a painting nor a sculpture. So therefore, being a painting or a sculpture is not essential to something's being a work of art. So the definition is therefore too narrow, right? Going back again, it's too narrow. And it also doesn't provide the essential definition of something because, again, Charles Dickens' Oliver Twist is a work of art, but it is neither a painting nor a sculpture. Here's another one. Well, I guess we already did this one, right? Music is the poetry of the mind. It's a bad definition because it's vague and it's figurative. It doesn't really tell you what the mind is. It's just it's figurative language. Okay. A couple more examples. By analysis, we mean analyzing the contradiction in things. Okay. This, I believe, was it Engels, perhaps, a follower of Marx. Does everybody agree that this is circular? I'm defining analysis in terms of itself, which is a circular definition. By analysis, we mean analyzing the contradiction in things. So it's clearly a circular definition. Okay, what about the one below it? Faith may be defined as the illogical belief in the unbelievable. Well, clearly, that has no meaning, right? It means nothing, right? It's vague, it's flowery, it's figurative. Who the heck knows what it means? So that's the problem with that definition. What about the next one? A cloud is a semi-transparent mass with a fleecy structure high in the atmosphere. Well, that's not a very good definition of cloud because there are a lot of clouds that are not semi-transparent, and a lot of them are not fleecy, nor are they high in the atmosphere. So this definition suffers from the flaw that it's inessential, right? It's also too narrow, but it's also inessential. And the last one, life is the art of drawing sufficient conclusions from insufficient premises. I think you would probably agree doesn't mean a heck of a lot. It's figurative, it's vague, and so again, it's not a very good definition. All right. So on the assignment uh, that I will post this coming Thursday, that'll be due the following week in your lab, I will give you some definitions and ask you to assess them in terms of the 5 rules. I'll give you some definitions and ask for you to classify them. Are they intentional, extensional, what type? And, so that will be one of the tasks on the assignment. And of course, again, I will have you do scriven diagrams to identify argumentative structures and passages. Okay, so that's all for this week. I will see all of you next week in synchronous lecture number 3. In the meantime, have a great week, and I will see you next week. Thank you.